So today, as I've been saying, we are going to discuss about the unit 11, 12 and 13. And here we have got some slide which will speak about them. First of all, we should know that these three units, they are very related. The first one speaks about the principle of homeostasis. This one defines what is homeostasis and it discusses its mechanism. The unit 12 is about regulation of glucose. This one describes the side effect of high and lower blood glucose level in the body and how our organism reacts to keep it constant. And the unit 13 is about the regulation of temperature. This one describes how the body behaves to maintain a constant the body temperature. So, what is the key idea about the unit 11? Here we should first be able to define what is meant by homeostasis. Homeostasis is the self-regulating property or ability of organism or living being to maintain a constant internal environment. So, our body should be able to maintain constant internal environment. There is external environment. The weathering around us, that is external environment. But the inside of our body, our blood, the fluid moving there, that is the internal environment. So this internal environment need to be kept constant despite of the changes of the environment. So homeostasis is generally carried out by a mechanism known as negative feedback. We can also find a positive feedback. What is the difference? Negative feedback mechanism is when the output is used to reduce the input. The terms seems a bit confusing, but what we can get it through this example. When the glucose becomes too low in our body, that is an output. The amount of the glucose becomes too low. What has caused that? It was caused by the insulin, because the effect of the insulin is to reduce the blood glucose level. So we say when the glucose becomes too low in our body, that is the output, the release of insulin hormone, that is input, switches off. To mean the pancreas, which has been producing the insulin, will stop because the output, that is the lower blood glucose level, has increased. By the positive feedback, we can see it as a mechanism where the output is used to enhance the input. So the output promote or enhance the input. For example, the more a breastfeeding mother produces milk, that is the output, the more prolactin hormone is produced to stimulate mammary gland. So when we produce the milk, instead of switching off the input, it will just enhance or promote the input. So it is always advised for ladies when they are breastfeeding to keep on giving the milk to their children, and they will produce more milk. So we should know that when we speak about the mechanism of homeostasis, there are three main components. It should contain, or it should have, a receptor. The receptors, they are biosensor that monitor and respond to the changes in the environment. The receptors, they can be found like on our skin. Our skin can detect, can monitor that there is too much coldness or too much heat. So it will send an impulse to the second component, which we call the control or integration center, that sets the range at which a variable is maintained. Now, that control or integration center is the one to decide that no, what we are finding is too much or is too low. So we want to bring it back to the normal set. So that is the role of the control or integration center. And we have also what we call the effector. So those one will be now in the label. What is their role? It receives the signals from the control center and it brings about the changes to the normal set of value. So it can see that no, there is too much sugar, let's bring it back. What to do to bring it back? Maybe we should consume too much sugar, or we should take that sugar, we transform it to make it, to make the glycogen. It is a way of reducing sugar in our body. So that was the key ideas. That were the key ideas about the unit 11. Now let's speak about the unit 12, which is all about regulation of glucose. You see, when I was speaking about the unit 11, I spoke a lot about the regulation of glucose. And this unit is now focusing. As I've been telling you, the three units, they are related. It's all about the regulation. The first one, unit 11, speaks just the general principle, which should be by a mechanism of feedback. And the second one focuses now on the regulation of blood glucose level. We should first say that the glucose is a very important source of energy for all body cells. All body cells, they need glucose as source of energy. But excess glucose, that we call hyperglycemia, or having the lower level of glucose, all this is risky in our body. So it can cause, when we have excess sugar, it can cause the conditions we call diabetes mellitus. So diabetes mellitus, we'll see what are the characteristics of that disease. But let's know that the normal blood glucose level of a human being is around 70 to 120 milligram per deciliter. That should be 12 hours after taking the meal. So after you have eaten at the evening, so we take 12 hours, then they can take the sample of your blood, they see if it is in that range, they say you are normal. But if it becomes too low, below 60, they say you suffer from hypoglycemia. And when it goes above 108, they say you suffer from hyperglycemia. So for this regulation of blood glucose, we have two main hormones which comes from the pancreas. These are the hormone known as antagonistic hormones. They are insulin and glucagon. Insulin is produced by the cell which we call the beta cells of the pancreas, while glucagon is produced by the alpha cells of the pancreas. So insulin reduces the amount of glucose in the blood, while the glucagon raises the amount of blood glucose level. So we have, apart from that, when we'll be reading our note, you'll see that we have two other hormones coming from the adrenal gland. These hormones, they have the role of rising up the blood glucose level. These are epinephrine and adrenaline. Adrenaline and epinephrine. Adrenaline is generally known as fight and fight hormones, to mean when it is secreted, you are ready to fight, you are ready to run, to run away. So, in so doing, it has the effect on our amount of glucose. It will go to mobilize the glucose which has been stored in our body in form of glycogen, and it will bring it in the blood so that you can have more energy to fight or to run away. But I don't advise you to fight against the lion, but you have to run away if possible. So this diagram is showing the general flow of the changes about the blood glucose level. What happens? Starting from the top there, if the blood glucose level rises up, what will happen? I go to the right side. The pancreas will release the insulin. And what will be the role of the insulin? Insulin will go to different target cells, and it will go also to the liver. And there, it will make different cells to start consuming the glucose in cell respiration, and also it will make the liver to convert the glucose into glycogen. What will be the outcome? As the glucose is consumed and as it is condensing to form the glycogen, its amount in the blood will decrease. So we say, I'm down there, we say the blood glucose level will fall down. It falls down. So after falling down, the body can say, no, I still need the glucose. What to do? So somebody who has his money in the account can say, okay, if I don't have money, the pocket money, let me run to my bank and I'll take more money. So by that time, the pancreas will detect that the blood moving has less glucose. By that time, it will release the glucagon, and the glucagon will act on the glycogen to break it down in order to release more glucose. The amount of glucose will increase again in the bloodstream. So it is a kind of cycle. There you are finding that these two hormones, they are antagonistic, to mean the effect of one is opposing the effect of the other. Why? We are seeing insulin is reducing the amount of blood glucose level, while glucagon is raising the amount of blood glucose level. So let's focus on the last unit, which is about regulation of, here we wrote a mistake, we say regulation of glucose. No, it is regulation of temperature, right? Regulation of temperature. We should be careful with that, not the regulation of glucose. In unit 13, it is regulation of blood temperature. We should say that there is a need to keep a constant the temperature of our internal environment. Why? Because if there is too much heat, it can denature the proteins by losing their secondary and the tertiary structures, and also it can denature the enzymes. And you know that most of our metabolic reactions, they are under control of the enzymes. So if there is no enzyme, so all the reactions will stop. Some organisms, they are able to keep constant their body temperature, their internal environment. These organisms, we call them homeotherm or endotherm, or we can also call them the warm-blooded animals. These animals, they are capable of maintaining the constant body temperature by generating their own body heat independently of the environmental temperature. They include mammals and the birds. So, This organism, they have got in their brain, they have a part which we call the hypothalamus. That part is the integration center for the thermoregulation. When I say thermoregulation, you understand it is regulation of the temperature. So the hypothalamus has got two parts. There is a part we call the heat gain center, and another part we call it the heat loss center. We have receptors. Receptors, they are basically located on the skin. The skin can detect that it is hot or it is cold. We have also the effectors. Effectors, where do we find them? We find them on the muscles, almost all muscles, especially the erector muscles, which are in the skin and which makes about the shivering. They make the hair to rise when it is too cold. We have the sweat gland. We can also have the wall of the blood capillaries. So what happens? When it is too cold, the one we are calling the heat gain center will cause the following. It will cause what we call the vasoconstriction. What is meant by vasoconstriction? Vasoconstriction means a narrowing of the blood capillaries. And you know this principle of physics, which says that the pressure is equal to the force over the surface area. So when the surface area decreases, the pressure will increase. So when it is too cold, there will be vasoconstriction. That means the capillaries will become very narrow and the blood will have high pressure. They will be running now very fast. That is not enough. You can realize it when it is too cold. If you don't have any jacket, any blanket, what happens? The outcome, you start shivering. Sometimes you see people, they are shivering like some puppies. Just see somebody shivering. So that is in order to produce the heat, to produce the energy. What can come again? We can have now the contraction of the erector muscles, which are in the skin, and this will make the hair to rise. We can also find the increase in metabolic rate. By metabolic rate, you understand here, the glucose should be consumed, and this glucose, as they are consumed, they produce the energy, they produce the heat. So that's what happens when it is too cold. But when it is too hot, can we be shivering? No. First of all, we should see that the heat loss center will be stimulated and it will send the impulse to different effectors. This will cause the vasodilation. Vasodilation is the opposite of vasoconstriction. I say the vasoconstriction, it becomes very narrow. The lumen of the capillary became very narrow, but this time they will become very wide and the pressure will decrease. The next, the sweat gland will be activated. There will be the onset of the sweating. You will be sweating, and by sweating, you are losing the heat, you are losing the temperature. So another activity which will come is that the erector muscles, they will relax. We'll have the relaxation of the erector muscles so that the hair may lie down, and there will be the decrease in metabolic rate. All these, they will have the role of reducing the amount of the heat. So those are the key elements we could speak about these three units. Questions here. Question number 1. What is meant by homeostasis? What is meant by homeostasis? Question number 2. Differentiate between positive and negative feedback mechanism. Differentiate between positive and negative feedback mechanism. Number 3. Explain how our organism control the blood glucose level. Explain how our organism control our blood glucose level. Question number last. Explain the role of the hypothalamus in maintaining the body temperature. Explain the role of hypothalamus in maintaining the body temperature. Thank you very much. I guess I will see the answers to this question in a few days. That means not later than Monday. Have a nice evening.